Oh, interesting. It's possible. So one, oh, I guess I should have elaborated on this more. Is that you can notice that in the problem they say that s is less than 10 to the power of 10 to the fifth. So it's 10 to the power of 10 to the fifth. And what this means is that you can't actually input the integer you can't actually input it as like an int type or a long type because 10 to the power of 10 to the fifth is very large. It's one with 10 to the fifth zeros after it, right? So you had to input the number as a string, and then use that to check whether or not the last digit is zero. I think, and you can notice that in the last three test cases, they actually don't know how to write Python that well, but you can notice that in the last three test cases, the input string can be very large. Yeah, which is why that might have been an issue. Okay, I don't know what's happening to this whiteboard because this happened last time. Wait, give me a second. Oh my goodness, because I remember last time we had the issue when this whiteboard was uh, but this whiteboard wasn't letting me write on it. This is really unfortunate. Oh, okay. Sorry, I'm having technical difficulties again. Oh my goodness. I don't know why it suddenly switched back to one of the new whiteboards instead of the classic ones. Sorry, let me figure something out for that. Sorry, technical difficulties. Okay, I don't know what happened to the Zoom whiteboard, but I'm gonna try to screen share to an online whiteboard instead. Really don't know what went wrong with Zoom all of a sudden. Oh my goodness, this is very unfortunate. Ah, okay, this works. Okay, so now for problem two. Um, so in this problem, you have n cows that are standing in a circle, right? And each cow initially has A of I amount of milk. And after 1 second, they're going to pass 1 unit of milk either to the left or to the right. And the question is, given all the initial given all the initial amounts of milk and the direction each cow is going to pass their milk in, what is the total amount of milk that all the cows have after m minutes? And that's his question. So, I guess one of the important things is that first, so let's say we draw the cows, like this. Alternatively, the cows might look like this. So the most important, or one of the important things is, for instance, if all of the cows are passing the milk in the same direction, then after 1 second, no milk will be gained and no milk will be lost. So in the event that this happens, then we know that I should oops. Yeah. We know that if all the values in S are the same, then the total amount of milk will be conserved. So in this case, the answer will just be the sum of A of I. And it wouldn't matter how many minutes pass, no milk can be gained and no milk can be lost. So we'll pretend that there exists no cases or so we've covered all the cases where um like all the entries in S, as the problem statements call it, are the same. So okay, so then we'll notice that the problem statement actually looks a lot more than the case here on the left. Of course, it can be a lot more than that, but it'll look like you have a bunch of cows who are all passing milk in the same direction. And then you have two cows who are passing milk between each other. And there's another cow on the end, the other few cows on the end that are passing in the same direction. This is in general what it'll look like. So for instance, what you can notice is that first this looks kind of like this, right? And you can notice what happens is that for these two circled cows, they'll maintain the same amount of milk because this cow will give 1 unit to this cow, so this will be plus one and this will be plus one. So in the course of a second, for these two circled cows, they won't gain or lose any milk. Alternatively, for this giant chain of cows, if you treat them all like as one giant conglomerate, they'll lose 1 unit of milk because this giant group of cows will try to send 1 unit to the circled cow, but the circled cow isn't accepting any more milk. So that unit of milk will be lost. And this will keep on happening for m minutes until either this group of cows runs out of milk or m minutes have passed and we've lost a total of m units of milk. So, yeah. And then, oops, probably should erase that. And you can notice that the same is true for this half as well. Is that this group, or of course here there's only one cow. This group of cows will also lose 1 unit of milk in the course of a second. And this also will continue until either n minutes have passed or they've run out of milk. So this is the crux of the problem. The crux of the problem is first off, determining what these groups of cows look like, and then summing up the milk contained by them, and then finally adding that to the answer. So let me erase this drawing. So another important fact is that since the cows are arranged in a circle, we can rotate both the array and the string by some amount, and the answer will still be the same. So for instance, in the first sample, it looks like RRL 331, right? But we can rotate this. Um, oops, it's not 3, it's supposed to be 1. We can rotate this, and the answer will still have to be the same because since it's a circle, it doesn't matter which point we start at, right? Okay, so now let's and also we know that the starting string, or yeah, the string is going to have at least one character that differs from the other. Um, of course, in the case it doesn't, we handled that case earlier. So what we can do is we can rotate the string. To implement the solution, we can rotate the string to some index such that s of n is not equal to s of 1. And I'll explain why this is helpful later. So we can first rotate the string to some position where that is the case. And then afterwards, what we can notice is that for each block of the string will now be split into blocks of characters that all have the same value. So we can have a bunch of R's in a row or a bunch of in a row, or we do a singular L at the start. And in particular, the blocks don't go over, the blocks like don't wrap around the string since we rotated our string in a way where that wouldn't be the case. And the other thing we can notice is that in a block, if this block, for instance, in this block of all R's, it looks like this, right? Where um, the the cow at the very end of the block is the one is like the circled cow from the example earlier, that's gonna have its milk amount conserved. And then all the cows that are to the left of it, yeah, all the cows that are to the left of it will end up losing 1 unit of milk over the course of a minute. And similarly, if we have a block of L's, the cow that's on the very left is going to be the one that conserves the amount of milk it has. And then all the other cows to the right of it will lose milk over time. So we'll lose milk over time. So what we can do is we can first split up the string into these blocks, and then for each block, we consider the element on the very end and all the elements to either to the right or the left of it, depending on whether the block is R or L's. And we can first take this sum. Just call this sum, and then we can call this element X. And what we can do is we can so for sum, oops. So for the sum, we can the amount that it'll add to the answer is either let me erase some of this stuff up here. So the sum will add oh goodness. The sum will contribute this much to the answer. And the reasoning behind this is that for over the course of each minute, the sum will lose one value. So it'll be sum minus n. But it's impossible for you for this group of cows to contribute a negative answer to the total because when they run out of milk, they'll just stop losing milk. So it'll be the max of sum minus m and zero. And then as for the x will just contribute x units of milk because no amount of milk will be lost from this particular cow. So, and then similarly, here, this will be the sum, and this will be the x. So, yeah, and that's the total. So that's the solution for this problem. Of course, some careful implementation needs to be done to make sure you actually rotate the string correctly. But the this is the final solution, and it should be O of n. And also note that due to the constraints of the problem, it might be necessary to use long or 64-bit integers to store the answer without overflow. Normally they'd have a bolded warning at the top, but I guess they didn't add any this time around. As for code, I'll send code later in the chat, but that's a long or in C++, a long is a 64-bit integer. And it can store values up to 10 to the power, or it can store values up to 2 to the power of 63. Yeah. Or in, oops, my goodness, I don't know what's happening with my pencil. 2 to the power of 63. Yeah. So that's that's all for this problem. Yeah, I'll send code. I'll send code in the chat. And I think that that should be it from me, and the other person or Arvind will explain the third problem.